container display. So for constructing built-in containers, lists as tuples or dictionaries, Python provides special syntax called displays. There are subtle differences between the four kinds of displays detailed in the following sections. All displays, however, consist of comma-separated items enclosed in paired delimiters. For example, a list display, a series of expressions enclosed in square brackets. In lists, tuples, and displays, the series might be empty. If the series is not empty, the items may be followed by an additional comma, which has no effect. Link comma is often used for displays that span multiple lines. At runtime, when a display is evaluated, the listed items are evaluated from left to right and placed into a new container of the appropriate type. Right. Now, for tuple list and set displays, I wonder if we say this for list, tuple, and dictionary displays, and tuple list and set displays, should also mention the one that is not included. Right. As I'm reading this, this question comes up in my head, like in list, tuple, and dictionary displays. Like, what's the other one? So there are 4 of them, and one is missing. Find it.
Right. No, fair enough. List, tuples, dictionaries.
So
is it set? Oh, comprehensions.
So set displays must not be empty, and this is tuple list and set, but not dict. This now looks kind of bad, but it's more informative. For tuple list and set but not dict displays, any item in the display may be prefixed with an asterisk. This denotes iterable unpacking. At runtime, the asterisk prefix expression must evaluate iterable whose contents are inserted into the container, and the location of the unpacking. For example, have 2 numbers and you kind of duplicate them here. This is a weird example, but it's also a list display, so it should have square brackets in the result. Dictionary displays use a similar mechanism called dictionary unpacking, which is a link that goes somewhere. Maybe this should link to the whole section. When you click this, it's not really clear that you're supposed to now start reading from the top.
I see, right.
I mean, we could use another level of heading, but we're really deep now. I probably don't want to add another one. So what do we do here? So this similar mechanism called dictionary unpacking. See the dict section, which is somewhere. Dict. I love these extremely small identifiers. Back when the docs were 10 pages long, you didn't have to disambiguate anything.
Right.
Right, dictionary displays a similar mechanism called dictionary unpacking with a double asterisk. The dictionary displays more details. There's 2 paragraphs of stuff and then dictionary unpacking, which should be fine. More advanced formal displays are comprehensions, where items are computed via a set of looping and filter constructions. See the container display section for details. Oops, we are in the container display section. This should be comprehensions. Comprehensions should be somewhere below. Comprehensions. To do. This is where we ended. Alright. Okay, list displays. Possibly empty series, unclosed square brackets. Say container displays for general information. In case you got a link here, you get redirected back. The formal display is quite simple. Set displays. Set display is a non-empty series of expressions. The same structure here. There's no special syntax for the empty set. This is a dictionary display. Should this say what you normally use for the empty set?
What do we normally use for the empty set? We just use the
Just use the constructor.
Yeah. Yeah. Yeah, it's probably a good idea because it explicit is better than implicit, right? Sure.
Set is a class, but kind of also a function. Apparently this is fine in Sphinx. You can call it a function. And
Okay.
huh. Oh, weird. Should this be a class? But if I say it's a class, I don't get the parentheses.
Shit.
So,
well, you could.
Oh, this run. I mean, yes, I could, but this render's better. Okay, so class set.
Yeah, exactly.
This is probably the correct thing to do. Yep. All right. A call set with no arguments get an empty set. The formal grammar for set displays is this. Notice the lack of the optionality here. Well, you don't need to notice, it's been explained. So, tuple displays. Tuple displays a series of expressions enclosed in parentheses. For example, blah 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 blah, an empty tuple. So this example is kind of bigger than the previous ones. I'm thinking we should omit this. And so this is here to make it clear that these are expressions. So this is from the previous pull request, which put tuple displays first. And if you want to do this, it should probably go here. How obvious is it that these can be arbitrary expressions and not just literals? Do we need to point that out in an example?
Yeah, I think so.
Plus 2, 2 plus 3, something like that.
Yeah, that's great.
So that's 3 and 5. Copy this so we can be sure it's correct.
Yeah.
I'll probably do the Pepe thing. Except it's not really a Pepe thing. Is this more readable?
Dun, dun. 1, 2, 3. Well, I mean, the thing is, it's it's very clear that they're expressions, right? 1 plus
Right.
2, 2 plus 3. Whereas the other ones could easily be confused with just strings.
I guess.
So, yeah.
So, yeah, if I had this in a program, I'd probably omit the spaces to make it more obvious that these belong together. So what does Pep8 say on this? Always surround these binary operators. If operators with different priorities are used, consider adding white space around the lowest priority. So yeah, I should do this. Use your own judgment, never use one with more space, and always have the same order of white space on both sides. Ah. Well, this is probably what I played once. Although I could argue it. Alright, so let's go on. Where were we in tuple displays? To avoid ambiguity, if a tuple display has exactly one element, it requires a trailing comma. Without it, you get a parenthesized group. To put it in other words, tuple displays parenthesized lists of either two or more comma separated expressions or zero more expressions, each followed by a comma. Which corresponds to the formal grammar then. Oh well, it doesn't. So this is just other words of putting it. Since tuples are immutable, object identity rules for literals also applies to tuples. At runtimes, two occurrences of tuples with the same values may or may not yield the same object. Python syntax also includes expression list, where a comma separator list of expressions is not enclosed in parentheses, but evaluates to a tuple. In other words, when it comes to tuple syntax, the comma is more important than the use of parentheses. So yeah, the current docs say what do they say? Do they even parenthesized forms, right. Tuples are not formed by the parentheses, but rather by the use of the comma. And this is really unfortunate wording, because forming by parentheses is not really well defined. And okay. You can well, hopefully with this pull request we'll be introducing tuple displays as a term, and tuple displays are the thing that has parentheses around the tuple. Well, of course, there are some tuples which do not use the comma, which are the empty tuple. So I think comma is more important than parentheses. Is vague enough to be correct, and still useful. Only the empty tuple is spelled without a comma. Formal grammar for tuple displays is this, and I hope this was copied from the actual grammar. It's really complicated, unfortunately. Anyway, next up, dictionary displays, possibly empty series of dict items enclosed in current braces. Each dict item is a colon separated pair of expressions. Is dict items something we had before?
I think yes. Yes, I think so.
You know, I'm kind of looking at the use of dictionary versus dict.
Oh, I see. Okay. Maybe
dictionary is kind of the formal name you would use in prose, so it's used everywhere here. But then I switched to dict here because I just want to make this shorter. It's already in parentheses. This depends on the reader knowing that dict is short for dictionary, which I think is quite obvious even if you didn't know before, and if you're reading reference documentation for grammar, probably know that, so we're fine. And here we're defining the term dict item that we can just use anything we want. So this is also fine. So each dict item is a colon separated pair of expressions, the key and its associated value, for example, blah blah blah. At runtime, when this is evaluated, the expressions are evaluated from left to right. Each key object is used as the key to the dictionary to store the corresponding value. This means you can specify the same key multiple times and the final dictionary's value will be the last one given. For example, 1, this will be overridden 2, 2, 1 also overridden 1, 1. This should be on separate lines to be more obvious, right?
Oh, good catch. Yeah.
So how do you use the new REPL?
Oh, the new REPL?
Yes, this REPL that can do multi-line expressions.
Oh, how cool.
But then when you press enter, there's no way to tell if that ends the like whole input or gives you a new line. Or at least I don't have that in my finger memory just yet. And and this also subtly tells you something about how dictionaries preserve the order, right?
Ah, yes.
Because here there's 2 and there's 1, right? So you first put in this entry and then put in this entry, but it really preserves the order the keys are put in, not the, like if you put in another entry it doesn't remove the old one and append the new one. Anyway, so instead of a key value pair, a dict item may be an expression prefixed by a double asterisk. This denotes dictionary unpacking. At runtime, the expression must evaluate to a mapping. Each item of the mapping is added to the new dictionary. As with key value pairs, later values replace values already set by items and unpackings. This may be used to override a set of defaults. So the defaults are color blue, count 8, overrides color yellow, do that. Overrides that. This is a nice useful example. I like that one. And that's where we ended last time. So those were displays, and we said that more advanced forms of displays are comprehensions. So now we need to pick up there and convert all of this to something coherent, right? So maybe start by repeating this. In case you got linked to this section. So comprehensions are a form of displays.
Yes.
And displays, right? where items are computed by a set of looping and filtering instructions. There are list, set, and dictionary. Comprehensions. There are no tuple comprehensions. Similar syntax is used by generator expressions. Which is the next section. Might need to rework that as well in this pull request. Maybe comprehensions are form of or list, set, and dictionary comprehensions, or a form of displays. Does that make sense?
Yeah, I feel like we did something like this a while back. Looking at my notes here. Looking at the previous session notes.
Oh, here it is. There are no tuple comprehensions, so similar syntax is used for generator expressions. So shall we start with an example? We already did this, right? We have a good example here somewhere. We don't. So, for example, a list. We probably want to be explicit about the type. A list of the first 10 squares is x squared for x in range 10, right?
Okay, yeah.
So what do we want to say here? So previously this was kind of combined with the displays, but I think the like the normal displays really should have a section to themselves, followed by all the weird special cases, and then we can have comprehensions as like more advanced chapter, even though comprehensions are displays. So previously we had
Yes.
this. So each displays come blah blah blah. Each of the like in 3 or 4 forms. Each of them in 2 flavors. Either the container contents are listed explicitly. Oh, this is nice. We should reuse this one. Listed explicitly. Okay, where was I? Oh, so we need to use this index for if async for comprehensions. Okay, so previously we had the list, and here's the meat of the docs we want. Hi Stan, how are you?
I'm good, yeah. Thanks for the nomination again.
No problem. Thank you for being helpful for, how long was it? 2 years?
A little less, I think.
Maybe a year and a few months. Okay, the comprehension consists of a single expression followed by at least one for clause and 0 or more for or if clauses. So you always need a for clause, and then you can mix for and if. Right, so you can have this thing that people think is really confusing. You can have multiple for clauses. You can have if. I don't know. I'll take just the odd ones. You can have more ifs. But you cannot start with an if. So there's a single expression followed by a for clause. Let's see if we can do let's do the simple things first. So in simplest form, comprehension consists of a single expression followed by a for clause all enclosed and paired delimiters. So this is a list of the first 10 squares. Maybe we should have a set of what's a good example? What would you use a set for? That you could construct on a single easy line.
Yeah. It's funny. I seem to be running. I used to use such a lot for something, then names, month, days of the week.
Like you can deduplicate things.
Yeah, that's what I'm thinking of. Is for when you want. I use them for deduplicating stuff.
What do you want to deduplicate? And you also need it to be a comprehension. So deduplicate with some operation. Lower is probably a good one.
Oh yeah.
But what do you want to deduplicate?
I almost want to ask an AI. What are some good suggestions?
I'll go ahead.
Yeah. Let's see. What's URLs maybe?
That smells of a security vulnerability. Do something very simple with URLs. You'll regret it for the rest of your life.
Yeah, really. Like I used to use them a lot when I crawled. I would crawl pages and then figure out like, okay, what are the pages?
Right.
You know, for deduplicating like the names of pages that I was crawling.
Okay, so let's use a set of letters again. We'll probably go through this.
Sure. Well, yeah, we can do like a set of letters. Yeah.
And a dict. That's a good function. Built-ins. The exceptions, of course. How do you do? Oh, tab. You do more. Any. Okay. that a good example? This is usually what I use. What I use dictionary comprehensions is attaching names to things.
Yeah. Any, yeah, that's great. Yeah. Oops. Oh,
I probably should make them actual functions. Stir. Stir's a class. Hex. I know hex. Right. So when a comprehension is evaluated, can we reuse something here? So now my dilemma is: do I explain things now for the simple form, or do I go for the more advanced form with more for and if statements?
Let's see here. How about
Let's do the more.
Yeah, do the more
advanced
exactly
thing first. So the for clause may be followed by 0 or more additional for or if clauses. For example, right, so what do we do here? Is there a good Okay, this is probably not a very good example, because what the hell does this even mean? X plus y for x in range 10, for y in range from x to x plus 10. Yeah, I'm doing some meaningless examples here, but this is not really obvious. So, better example. What do we do? So we can import two modules and give you all the functions from the two modules that belong with a specific, that begin with a specific letter. Like
Oh,
import built-ins, then you import, I don't know, math, and
Yeah.
then you make a list of
the names of the
the
inputs.
names of functions for, and now you need to list the two modules.
That sounds pretty cool, actually.
Math for f. Well, let's see. Name and vars of that module if the name starts with the f. Do we have any? Format filter float version set fabs factorial for. These are the math ones, right? It's built in factorial floor FMAF mod f sum. As that's should probably split it up. Okay, I'm not good with this new rebel, sorry.
That's fine. So, how do you explain this? Here is a list of names composed by two Python modules that start with F. And yeah, that is not very helpful, but in my defense, this feature is not very helpful itself, so. Hmm.
So yeah, it might be better to either do filtering. So do the for clause, then cover for followed by if, and then get into the more general mess.
Okay.
So what would be a good case for filtering? Like if consider this being a good example in the first place, so instead of that we could do if x is lower, or maybe do something with globals.
Oh.
No, we don't really have globals available in this context. Maybe do something with dir. Like all the non-underscored attributes of the integer class.
Oh, wow. Okay.
The for clause might be followed by an if clause. To filter out expression. For example, here's a list of all attributes of the class, right? Int that don't start with an underscore. Or maybe, for example, dir int gives of goes to the of int a comprehension with an if clause can filter out ones starting with an underscore. I have a feeling that this example is a little too practical.
Okay.
A little too practical and hard to explain because right now you're learning about comprehensions and now you need to switch to attributes.
Fair enough.
So we find a simpler but more useless example.
Sure.
Or maybe we could introduce this in one of the earlier examples. Somehow. Maybe reuse the example we used for there, which is struct. Okay, we don't want struct. Maybe that's something that has fewer underscored attributes. I don't think we have much of that, right? All of these will have lots and lots of stuff in them. Functions just have all of them underscored. And anything that's built in will have lots of these. Because it's a class, right? So. I don't know. Is there a better way to get some set of names to filter out?
Like, last names, vegetables,
Now the problem with last name and vegetables is you need to put in a string of them.
That's right.
Really like something that
yeah.
Python gives you. So if you import math and then let's get all the functions that start with f here and then expand the example. That work?
Sure, that's good, yeah.
this would be for example yeah, I guess that's a better example, and then we can expand it to more for. Should we add more for and if? Now, if is actually like you can have more if clauses, but it's not very useful. Like you can have ends with something else, for example, and it's not really useful because you can always put an or and add more filters that way. I guess you could add an if after the for, which is why, why more clauses are useful. Okay, so looking at the big picture, we have the simple examples. This is missing the saying, what the pair delimiters should be for the different types. It's also missing the an explanation of the pair here. Then this should probably have some kind of explanation of what's going on when you evaluate it. Then we have the single if clause, and we need to say something about filtering, and we probably want this step because this is what people will see in the real world. And after that we can explain the full generality, which many people think is too confusing and you should rewrite that. And what we're also missing is start comprehensions. It seems you can do those. Oh, there's also async comprehension. There's too much. Implicitly nested scopes. Fun. How do we structure all of this? we have one to do here. We have another to do for well, scopes, which is mostly for nested fours. Yield and yield from. With asynchronous operator, asynchronous iterator. Oh, in an async def function you can have an async for clause. Okay. And a wait.
Yeah.
You can have a wait in comprehensions. Okay. Then it's called an asynchronous comprehension. So this probably will need its own subsection. Asynchronous comprehension may suspend the execution of the coroutine, which appears, of course. There are no tuple comprehensions. This this looks like something we should probably put in early on. And then dict comprehensions you can use with two expressions or with the double star. I don't think I've ever used that one.
Huh.
So what you can do, like this? No. Two expressions separated with a colon. That's the normal one. Single expression prefixed by the star dictionary unpacking operator. Isn't this? Yeah, this is nice. So dict comprehensions should probably have their own section. Key type should be hashable, yeah, of course. What? Where? Oh, this is Python 3.15. Oh, this was just added. Okay.
Oh, okay.
Ah, no wonder it doesn't work if I just put in Python. It's a pre-release version. Parse argument must have a dict attribute. Okay, so let me import built-ins again. And do this for the two modules. I'm behind on my Python features.
Oh, welcome to the club.
Okay, this is okay. So this just merged the two vars together, right? So name math because math is last. Doc. And there's package loader. Everything here's for math. But then you see ACOS. Where did built-in? Oh, here's all the built-ins. Right, so whatever is in both, or whatever's in built-ins comes in first. If it's in both, it has the value for math. If it's only in built-ins, it has the value for built-ins.
Cool.
And if it's only in math, it comes in last. So yeah, this is cool, but it's not a good example, of course. We need a good example. Where was this added? Let me read more about that addition. What's 315? Lists, set in dictionary comprehensions, as well generate expressions. Oh, this was a PEP. I remember that one. Oh yeah, I remember looking at it and thinking that this looks neat. Right, so yeah, you can combine iterables. You can get the union of iterables. You can combine dict iterables, and you can use it even in generators. Right, so you can do this, but you cannot. Okay, yeah, makes sense. Flattening a list of lists. Probably the best thing to do here. So if we do use examples like this one, I guess we could do this with list comprehensions. Or maybe do a smaller module. I don't know. Does context look better than built-ins? It's also pretty big. What's a good small module? Do some. Bunch of errors, bunch of functions. Still pretty big to fit on a line. Oh,
Path? OS path? I don't know.
Path? OS? OS path? That one's huge.
Yeah, that one's huge. Okay. Yeah.
Okay, not huge, but big.
Yeah, yeah.
Okay. There are some like really old modules. I don't know. File input. Do you know the standard library has the module file input?
Wow.
It still has a bunch of functions. Well, we have citadel module names, so we can do dict comprehensions, right?
Yeah.
Len import and put in the R's there. After importing the module for n and that. I cannot use WinReg because I'm not on Windows.
Okay.
And there'll be more of those. There's also WinSound and yeah. So this is the thing about comprehensions. You can rewrite almost all almost all pieces of Python code as a single expression, and comprehensions let you express loops. The one thing that's really
Right.
awkward to do as a single expression is error handling. So I'll need to go to normal loops. And if I go to normal loops, I need to, well, I don't need to, but it's better to use better variable names. Set import error. Go on, and now we print the name and the length of whatever it has inside. Okay. So we want to number of stuff in the module is this, and if that is smaller than 10, we print it out. Okay, so we're looking for a good example for documentation. Okay. Which one would be good? There's URLlib, which contains other modules mostly. There's Turtle Demo, idlib. Okay, let's see. Okay, it has stuff and testing. That's probably not a good example. Let me make this a single statement, single expression. So URLlib, that's just a container for other modules. I don't know why I have parse imported, but if I import like URLlib is open in here? No. Has more than parse. I don't know. It'll have more if I import more submodules. I don't know off the top of my head what those are. So next one, WhiskeyRef has nothing. It's probably also submodules. XMLRPC probably also. So PWD, but that probably isn't available on Windows. Yeah, all of these are
Zone info should be short.
what?
Zone info should be short now.
Zone info.
Let's look at more. Bunch of errors, and then these. Well, that's good. struct. So struct is the example used somewhere else we looked on. Did I import anti-gravity? Should open the browser. So for dir, struct is used, probably because it's a well-used module that's fairly small. I did import anti-gravity. Bisect color sys is nice. That's my favorite module. Some constants. I don't know if those are documented. Marshall. I guess pickle won't be here. Why is this not sorted? Array, good one. Color sys is fairly big. Secrets, fairly big. Struct looks good. Tomolimp. Okay, array looks good. So what can we do with array? It has a class, some metadata stuff, a private thing, and its type, and some string with all the type codes. So yeah, this is the one we should use probably, unless we go for color sys. And now I forgot why I am on this tangent. I'm on this tangent.
Oh, we were looking for examples. We wanted to be able to do any and set. And
right. So built-ins is too big. We want array here, right? Except array doesn't have anything that starts with F, so let's do this with A. Okay, so this combined two rather small modules, but the result is still unusable in an example. Now the problem with this is I can't really filter for the function name because it just takes it gets the names in here and just plops them in the resulting dictionary. But maybe what I could do is expand the example from here, right? So if you have like system defaults and user defaults, and then you have some overrides, and then you do D or D in all of these. Parentheses. Then you get all of them overridden in the order you gave that, which looks useful. I don't know if it makes a good example.
I unfortunately am going to have to leave in a few minutes.
Right. Well, this is a lot to think about for next time. But
it is, yeah. It's
I think we need to have subsections here because we have quite a lot of material to cover. So there should be filtering. Incomprehensions. And then complex comprehensions. And then we need asynchronous comprehensions, and perhaps somewhere we also need the star comprehensions. What are these called? Unpacking comprehensions, I guess. Okay, so that's a good place to stop and leave things for next time, I think.
Awesome. Thank you, guys. Cheers.
Thank you, and see you next week.